Hello and welcome back to class. Today we're going to start our transition into algebra. We've done some stuff with arithmetic and rational numbers and different sets of numbers, but we want to start using that logic in algebra. And remember, algebra is not just reserved for high school. It's algebra once taught in middle school in many places, but the fundamental concepts of equality and those sorts of things are also present in elementary school, even if it's just something as saying like, if I have a triangle plus 3 equals 5, what does the triangle equal? Students are doing algebraic thinking even at that point in the elementary schools. But to be a little less intimidating than just throwing algebra from high school at you right off the bat, I want to give you some logic and build up on just the thought of what equality is and balancing things, and not so much abstractly with numbers, but actually looking at actual balances. So in your resource packet, you'll see a worksheet entitled A Transition to Algebra, and usually this, along with the weighty problems worksheet I'm going to include, they usually take up a whole class for me when I teach it to my students at the college. And it's just because as they work on them, I go around the room and I like to see how they're thinking about things, what logic they're using. I like to question them, not question them, but question their process, try to lead them to the correct answer without giving it to them. Now, unfortunately, I can't do that with you because this class isn't we don't take this synchronously online. But what I can do is offer you the solutions worked out, and as you work them, you can pause the video, try it, and then learn from your mistakes as you see how it's done. That's the best way to do it. Don't just watch me do it and say, yeah, I could have done that. But your mind needs to be able to make mistakes in order to progress. So try the problems, pause them. You don't have to print them out. It's a lot of pages to print out, but you could pause it, work it through on a scrap piece of paper if you want to, and then come back and play it. Although I think the best way to do it is probably printing it out if you've got the paper and the resources. Print them out, and that way you can draw on them. So let's start off with the first one here. So this is saying this mobile balances. Based on that, can we say these other three things over here? So this balances, which tells me that 4 stars weighs as much as 2 flowers. And then in answer choice A here, what have we done? Well, we've added 1 triangle to each side. So assuming, all of these, we can assume that the same shape weighs the same amount. So a triangle equals a triangle. And so, yeah, we've balanced this. And notice what we're eventually setting up is eventually we'll have an equal sign in between here, and we're adding a triangle to both sides. So we're keeping the equation in balance, just like when you solve algebraic problems later on. On the next one, it says, can we say it balances? Well, we went from 4 stars to just 2, and over here we knocked off 1 star. So we keep that ratio the same. Notice 2 stars we could say is equal to 1 flower. So if we marked off 2 stars, we also have to mark off a flower, and so this is a yes also. So both of these are yeses. And then the last one says, will this balance? So going back to the original, we've taken 1 star and we've moved it over and hung it over here to get this. Is that going to be in balance? Well, think about it. If 2 stars equals a flower, and that's what all 3 of these really come down to, that 2 stars equals a flower. I've basically added half a flower over here, and I didn't add anything to this side where I subtracted half a flower. So no, it's not going to balance. This is going to be heavier, so that's going to go down and this side would go up. So this answer right here is a no. All right, pause the video, give this one a try. All right, so once again for this one, we've got circle and a square equal a heart. So circle and 1 square, say we can just balance it out like this. We've got a circle and 1 square equal 1 heart, and then this circle and this square equal the other heart. So this is going to be a yes, it does balance. On this one, we've got a circle and a square. That will balance with this 1 heart. But is 1 heart equal to 2 hearts? No, this one balances with this one, but we're left over with a heart over here, so this is going to weigh it down, so this is going to be a no. And then over here, notice this. we've moved the heart to the left side and the circle and square to the right side. Will it still balance? Yeah, it does. It doesn't matter which side it's on. And that goes back to our reflexive property. Remember we spoke in a previous lesson where we said if we have x equals 6, we can also say 6 equals x. If you have a heart equals square circle, then a square circle also equals a heart. So this is a yes also. Now this little note over here, don't get confused. We did solve what they were asking us to solve here. They mean like we don't know, we can't tell what the weight of a heart is, a circle or a square. All we know is the relationship between the shapes. That's what that note is saying there. All right. Remember, each time I turn a page, just pause it. I'm not going to keep reminding you to pause it. Pause it when I turn the page before I can start working it out for you. So it says this mobile balances. Use the key to translate it into an equation. So we'll use S for star, M for moon, C for circle, that sort of thing. Oh, I actually got it written right there in the key. So on this one, we've got a star plus 2 moons. They don't have to be separated like you see over there, plus a circle, and that equals 4 stars plus a moon. So notice we're going from a pictorial representation to actually writing it out in letters. We're transitioning here to more of an algebraic look to our problem solving. So it says draw the mobile that would remain if you crossed out 1 star and 1 moon on each side. So crossing out 1 star and 1 moon on each side gives me 3 stars and a circle and a moon. Do we know if these changes would keep the mobile balance? Yeah, they would. We're taking off an equal amount on each side, 1 moon and 1 star there. And then lastly, it says write an equation for this modification. So we can say a circle plus a moon equals 3 stars. And we could even look at it algebraically up here. If we crossed out a circle and a moon, not a circle, a star and a moon, that would get rid of this star, and it would get rid of 1 moon there. It'd get rid of this moon, and it would get rid of 1 of the stars and leave us with 3 stars there. So M plus C equals 3 stars. Just like we have right here, C plus M or M plus C, remember it's the same thing because of the addition, the commutative addition property there. So C plus M equals 3 stars. And then lastly in this, it says if the equation written out right here is true, then which of these equations are true? Mark true or false for each one. So try that out. So these are the answers that I got when I worked through these, so you can check them. For the first one, all you're doing is switching this original equation around the equal sign. So reflexive property holds there. You're taking this part, moving it over, and then this part right here, moving it this way. So everything stays equal there. On the second one, all you're doing is combining the like terms. So from part A. So these two get added together and make 4s, and that equals 2m plus s plus c. You're combining those two right there on the right side. So that also is true. On part C, however, it looks like what we've done is subtracted a star from the right side and added it to the left side. And that's going to throw it out of the balance. This is now lighter and this side's now heavier. There was no balance there, so that's going to be a false. On part D, notice what we've done is go to part B. If you move 4s plus m to the right side, and then this becomes the left side, and all they did was rearrange the order they add, which since additive is commutative, or addition is commutative, it doesn't matter the order you add those. You can say s plus 2m or 2m plus s, and then add c on the end, and it's still the same, so you're good there. For part E, if we were to subtract an m from both sides, subtracting an m from this side gives me just 4s. Subtracting an m from this side over here just gives me s plus m plus c, and then rearranging it. Or you could look at part B and just subtract m from both sides, and you'd get letter E there, so that's true as well. And then for part E, if you were to subtract s from both sides from part E, you get part, or answer choice F right here. So that also is true. So those are keeping it in balance. Only C is some algebra issues there where we did not keep the equation in balance. Now, for number 9, there could be a lot of different answers you could get here that's correct. So it's not really right or wrong if you get it the same way that I did here. So this says this mode will balance this, create one that is a new one that will balance as well. So all I'm going to do is just double both sides. So I had 3 on the left. I'm now going to make it 6. So there are 6 right there now hanging. And then for the triangles, I need to have 2 for every 3 to make it balance. So there's 2 for the first 3, and here's 2 more for the next 3. And then so my equation would be, translate both mobiles into equations. This says 3 circles equals 2 triangles, and this is 6 circles equals 4 triangles. And then on the right, I'm just going to remove a heart from both sides. Rip out that heart. And that leaves me with 2 stars on the right. And then we've got, looks like a little kite down there, a blue kite. And then a pentagon there. I'm just going to make it red because I don't have an orange pen convenient there. So there's our pentagon. When you're doing these for homework, you don't have to draw as well as I do here. I know I'm a pretty good artist. So long as I can somewhat understand what you got going on, I'll be happy with that. So the original one had a heart in it. Let's put the heart back in there. And so we've got 1 pentagon plus 1 heart plus 1 kite is equal to 2 stars plus a heart. Oops, don't get rid of that. Let's make that go with that right there. And then for our new one, we've got a pentagon plus a kite equals 2 stars. For this section, I think it's easier to translate this into an algebraic equation. So I'm just going to do that at the top. I know I got 2 hearts plus 2 stars is equal to 2 moons plus a heart. And you can even come up with a second equation by subtracting a heart from both sides and say a heart plus 2 stars equals 2 moons. That's subtracting 1 heart from each side. And so that might help us on a few of these. Let's see, this one says a heart plus 2 stars plus a heart, or same thing we got right here, equals 2 moons plus a heart. Well, that's the same thing I wrote in black there, right? So that is true. And what do you know? Part B is what I wrote in blue there. You're just subtracting a heart from both sides, so that's true. So far, so good. Now, part C says 6 hearts plus 6 stars. So I'm taking this original left side written in black right here, and I'm multiplying it by 3. So this side needs to be multiplied by 3 as well. 3 times 2m equals 6m, and 3 times h equals 3h. So this is true. And then the next we got 2 moons plus a heart. Let's see if we can come up with that somehow. 2 moons plus a heart, that's right there, equals a heart plus 2 stars plus a heart. So this can all be the same as part A right here. If you move this part to the left side and combine your m's, you get this. And if you move this part to the right side and combine the s's, you get this. So this also is true. Let's look at E. E says 3 stars plus 2 hearts. So originally we had 2 hearts right here, but we're adding a star right there. So we've got to have an additional star added right there for that to be equal. So we have 2 moons plus a heart plus a star. That works out to be true. And then lastly here for F, we have 3 hearts equals 2 moons plus 2 stars. The best I could come up with that is to look at this as we have 2 hearts plus 2 stars equals 2 moons plus a heart. That's from this original. And they get the heart by itself. So I subtract an h from both sides, and I get h plus 2 stars equals 2 moons. Subtract 2 stars from both sides, and you get a heart equals 2 moons minus 2 stars. That's 1 heart. So if I multiply that by 3, I end up with 3 hearts equals 2 moons. No, sorry, that needs to be multiplied by 3 also, doesn't it? 3 hearts equals 6 moons minus 6 stars, which is not going to be the same as 2 moons plus 2 stars. So this one is our first one here that's going to be false. All right, try out number 14. So for 14a, I'm just comparing it to their original equation here. It looks like they've got t plus 2p the same, but they subtracted an s from this. So we've subtracted an s here. Did we subtract an s on the right side? 2t plus 3s, 2t plus 2s. We did. So since they subtracted an s from both sides, the equation stays in balance, so this is true. Notice on this one, we're not saying what the t's and s's stand for. We have slowly transitioned into more of an algebraic approach to these equations. So part D here, t plus 2p. So we've subtracted 2 s's this time. Did we subtract 2 s's over here? We did. So that also is true. I kind of jumped down from A to D there. I just realized that. But that's okay. Let's go on over to B. For part B, what have we done? We've taken and added 2t to the original. But I don't see where we've added 2t here. I see where we've subtracted 2t. And then we've got 2p still. We've subtracted 2s, but we added 2s over here. So on this one, we're going to say that this is false. We're not keeping the equation in balance. We're not doing the same thing to one side as we do to the other. This one, we've got 2p and plus 5s. So we've added 3s to the left side, and we have subtracted t from the right side. From the left side also. So adding 3s and subtracting t, did we do the same over here? It looks like we added t and subtracted 3s. This also is going to be a false. Part C looks good. All we're doing is subtracting t from both sides, so that's going to be a true. And then for part F, let's see, we subtracted both the t and the 2s. Did we do the same thing to the right side? We subtracted a t to get t, we subtracted 2s to get just s, so that also is going to be a true statement there. Now, these mobiles sometimes confuse the students when they first see them. All we're saying is we're now taking and adding another balance in here. So these two right here balance, the two circles, is equal to one pentagon, and their sum, if you add them up, balances with this kite and this circle right here. So as we do this, we're assuming that the mobile itself does not weigh anything. So these bars or anything like that don't add any weight to it. So it's saying that this balances, if we were to write this out in an equation form, we'd say 2 circles equals 1 pentagon. And then we could also say that 2 circles plus a pentagon, the sum of these two, is equal to a kite plus a circle. So you could take this even further, subtract a circle from both sides, and say that a circle plus a pentagon equals a kite. That might come in handy, may not. Let's see what we've got over here. This one is just reversing what we have over here. It's changing the order, but it does, remember, addition is commutative, so it doesn't matter if we add them this way or add them this way, they're still going to weigh the same amount. And then we can reverse them, so the reflexive property holds there as well. So this is a yes, and it's because we're reversing the order. Now, this one, can we say for sure that that mobile balances? So I'm taking these two circles and that pentagon, and I'm just moving the pentagon there, and I'm just changing the order there, so this is going to be a yes also. If we look at C, D, and E, they're based on the same mobiles there. So we want to know, do these down below balance? I'm going to move, it's all the same question, so I'm just going to move up so we can see the original mobile again. And so as we look at the left side here, we basically have taken it, if you look at, let's look at this one over here, part B again. We're basically taking this and moving it to the right side, and we're not balancing it in any manner. So this is going to be a no. The right side is heavier. On this one, it looks like, we're taking this section and we're going to add this right here to the middle of it. and just ignore that that was ever a mobile. And in my opinion, this looks like it should balance then, because the weight is negated here in the middle. It's pivoting on that. So this should balance because we know a pentagon equals two circles. And then let's look at our last one. We've got this section right here, which should be equal to these two. And already that causes a problem because I know that this part of the mobile will not balance because this is equal to a pentagon plus two circles, and we're missing two circles right here for it to balance just on the inside part. So that's going to be a no as well. For 15 through 19, I've got some good news for you. That is, if you don't want to do it, we're not doing it, because it's not really part of the course. It's just part of this packet that I found for us to think logically, and so we're just going to pass by it. We got enough to do in this as it is. So here's your favorite section, the one that starts talking about tough stuff. Pause the video, try these out. So there's the first 6 answers that I've got for you there. This one says 2x plus b is equal to c. Earlier we had 2x plus 2b. All we did was subtract b from both sides. Part B, we have taken 2x and made it x, 2b and made it b. And so you could think of it as subtracting x and b from both sides, but it doesn't really match up with our right side. So the right side gives you a clue there. We're multiplying both sides by 1/2. And so if you multiply this side by half, over here you get x plus b. And then if you multiply this side right here by 1/2, you get c plus b, which is the same, actually 1/2 times c plus b, which actually means I marked that the wrong letter. It should be a t for true. Don't know why I did that. So t for true there. Part C, you got 2x plus a b minus c. So what have we done? We've subtracted c from both sides, and so that c goes away, and you have a minus c over here. And then subtracting b from both sides, you get just 0 on the right side and 2x minus c, and that's one more b left in there, so that works out to be true. Now, for part D, you've got 2x plus 3b equals c. So you're adding a b to both sides, or actually you're just adding a b to the left side and subtracting one on the right, so that stays a false there. Part E right here, we got 2x plus 2b minus c, so we've subtracted c from both sides, so you get a b left over on the right side. That one's good, that's true. And then 2x is equal to c minus b. We subtracted 2b from both sides there to get that. Try out 21. So for this one, we've got 4s that matches up. We've added 2t, but we didn't add 2t to the right side. We subtracted 2t, so that's how we get the false there. 4s plus m, we've subtracted a t. We subtracted a t from the right side, so part D is true. Going to part B, 4s plus t, we subtracted an m from both sides, so that works out to be true. Going to part E, we said 4s plus a t on this side, and then plus an m. Did we add a t over here? We did, and we added an m, so it's true. For part C, we've got a t plus an m, so we must have subtracted 4s from the left side, and then they make up for it by subtracting a 4s from the right side. And then lastly, they subtracted this t and the m, which would give us 1t and 2m on the right side there, so that's true as well. I'm going through these kind of quickly because I know a lot of you have a strong algebra background. If for some reason you need me to slow down, or if you need to talk to me or work things out, we can meet online, or I can give you some additional examples a little bit slower paced for you so that you can get these. But I don't want to waste too much of your time. We're already 25 minutes into this and we got a lot more work left. So looking at number 22, pause the video and try that out. So for this one, if we say that these are worth 3 each, that's worth 9. This is a 3. This is a 3. So 3 minus 9 is 6. So each of these must be 2. So they add up to 2, 4, 6 plus 3 is 9. And then so together, this whole thing right here weighs 18. And if that's 18, 18 minus 3 is a 5 for that. So we get 2 and 5 right here. For this one says that the whole thing weighs 24. So that's going to be 12 on each side. And then looking at the left mobile here, 12 is going to be split up into 6 right here for the square. So the square is 6. And then this right here must be 6. And so there's nothing here saying that two triangles must equal a circle. But I do know that we're just going to stick with whole numbers here for now. So I know that you can play around some numbers here. If this were say a 2, and these are 1 each, they would only add up to 4. So you could make this right here a 4, and now these add up. 4 plus 1 plus 1 gives you 6. This is also based off the assumption that a circle does not equal a triangle. So we've got 1 right here and 4 right there. And so we've got 4, 4, 1. This is in the middle, so it doesn't affect the balance, but we know that this plus this, or a pentagon plus a triangle, equals a circle, so the pentagon must be 3. All right, for the additional practice, I'm just going to post the answers. I'm not going to make you go through this part because I want to move on to some weighty problems. But if you want additional problems using the mobiles, I'll post this. Obviously you got it in your worksheet. If you're just looking at the screen, that's what we have here. And then we got one more page of that. So I'll post those answers to our classroom page so you can check them out and ask me questions if you do. If I need to make an additional video on it, I can. But I don't want to waste too much of your time because I know you've got a lot to do this week. Let's move on to the weighty problems. We've got 9, maybe 11 of these, I can't remember. But we'll work through these problems, and then I'll give you some homework problems dealing with these as well. So these begin fairly easy. You can see that it's not the mobile, it's like a balance. And I'll go ahead and give you a hint that sometimes these shapes weigh a negative amount, which kind of contradicts our physical thought there. But just assume that they're lighter than the air and they are stuck to the platform there they're resting on. So in this case, though, it's not. We can quickly see that a cylinder is half as much as a sphere because 2 of these add up to 1 of those, so the sphere is the heavier object. Now, none of these, we're not going to assume that any 2 objects weigh the same amount, but what we can say here is that a sphere plus a cylinder equals a cone. The cone is going to be the heavier object because you need both of these just to equal the cone's weight. On this one, they actually give us values for the weight. And so we know that we've got in part on scale B here 2 cylinders, and they add up to 10 pounds, so they're going to be 5 pounds each. Over here, we've got 2 cones, and they add up to 6 pounds, and so they're going to be 3 pounds each. So together, 2 of these are going to add up to 8 pounds. On this one, once again, we can divide A in half, and we get 2 each there. But on part B, we need to subtract that 2-pound weight because we've got a 2-pounder here plus a cylinder equals 7, so the cylinder must be 5 pounds. And I just kind of explained it to you so you don't have to write that part out. On this one, we've got, let's see, whoops, it's number 6. I skipped over number 5. There we go. On number 5, we've got 3 cones this time, and they add up to 12 pounds, so 12 divided by 3 gives us 4 pounds for each cone. And if that's a 4-pounder, the sphere must be a 6-pounder to add up to 10. The next one, we're going to get into some rational numbers here. We got 2 spheres add up to 7 pounds, so they must be 3.5 each. And so together, this right here, this part is 7 pounds. And so 7 subtracted from the 13 gives us a 6 pound for the cone. For number 7, a little bit more complicated for some students. That's fine. I want you to pause it if you haven't been pausing yet and try this one out because this one's a little bit tougher. So for this one, you can't directly say, I'll just divide by 2 or subtract something and get it, or subtract like one of these and get it. But the way I look at it is if we were to remove a cone, well, let's put it this way. We know that a cone and a cylinder add up to 7 pounds. So I've got a cone and a cylinder here I can subtract off of this scale, which is the same as subtracting 7 pounds. And that leaves me with 3 pounds for a cylinder. So I know a cylinder weighs 3 pounds. And then going back to the scale on the right, if I subtract just the cylinder, I end up with a 4-pound cone. So the cone is 4 pounds and the cylinder is 3 pounds there. For number 8, now we're going to throw back in some balances here. Now that we've seen a little bit of that logic in place, they're telling us that a cylinder equals a cylinder, and they want to know, circle the block that weighs more, a cone or a sphere. So since the cylinders are equal to each other, then if I subtract a cylinder here and subtract a cylinder here, I get a cone equals 2 spheres. So if I need two spheres just to weigh the same amount as a cone, the cone must be the heavier object. So going back to the same thought here, we want to know which one weighs more. Looking at this, I know that a cylinder, if I was just ignoring the sphere right now, a cylinder must weigh more than a cone because it takes 2 cones to do that. So let's actually mark off the one I know that's not going to be heavier. That is not going to be heavier. So now it's just comparing a cylinder and spheres. So this is actually getting us into what we call the transitive property. If this is equal to that, and that is equal to this, then we can say that this piece must equal this piece. And so it takes 4 spheres just to equal 1 cylinder. So in this problem, the cylinder is going to be weighing the most. On this one, once again, what can I rule out? Well, I know that a sphere is equal to 3 cones. So the cones are lighter than a sphere. So knock out the cone again, just like when you're doing your driving test, right? And then I know that it takes 2 spheres to equal a cylinder. So obviously the cylinder is going to weigh more than the spheres themselves. So once again, cylinder is the heavier one. And then the last one we're practicing today, let's look at this one. We've got which one is the heavier one again. Let's see, we know that a cone is equal to 2 spheres. So a cone is going to weigh more than a sphere. So a sphere is going to be the least. It says put a check mark on the one that weighs the least. So that one's going to weigh the least because you got to add 2 for a cone, you got to add 3 for a cylinder. But notice that if you were to replace these 2 spheres, looks like a sad face there, but these 2 spheres are equal to a cone. So you could replace that with a cone right here, and you'd still have to add something to the cone just to get to the cylinder. So once again, the cylinder is going to weigh the most. And I just noticed that on the other 2, I should have marked the one that weighs the least too. So let's go back and just do that real quickly on number 10. I kind of took the meaner route instead of just checking it. I marked it all the way out. It's the cone that weighs the least because you need 3 to equal a sphere. So that means you have a total of 6 cones would equal the cylinder. And then down here, let's see, this time it would be the sphere that weighs the least because you need 4 just to equal the cylinder when you only need 2 cones to equal the cylinder. So sorry about that. I should have checked those off as I was going through that. You have some homework problems tonight. I just want to do the first one for you, and then I'll leave the rest of the weighty problems for homework. So in this one we have 3 scales this time. That's why I want to go through this one with you. They're saying that a cone and a sphere is equal to 5 pounds. So just like we did with one of the previous examples, right here I just start looking for a cone and a sphere, and I see that again right here. So that's 5 pounds. But that 5 pounds plus the cylinder equals 8. So the cylinder must be 3 pounds. And so I write a 3 right here, which means the sphere, since these 2 add up to 4, the sphere must be 1 pound. So the sphere is 1 pound. And write a 1 everywhere I see a sphere, which means the cone must be 4 pounds. So the cone is 4 pounds. And you just heard me say it. You can make me a video if you want solving the problems. You don't have to worry about explaining it then. Or you can just kind of give me a step-by-step procedure of what you did. Okay? So that was some mobile problems. There's your weighty problems, and hopefully you can see how we quickly transition into some algebraic thinking just by our physical relationships we're used to seeing, the weights and measures, balances, and things like that, to start to see our properties of algebra exist in just simple things like scales. As you do your homework tonight, don't forget that some of these, I know at least one problem, I can't remember if the second problem, has some negative values to the shapes as far as weight goes. That seems a little strange when you think about the practical sense to it. Algebraically it works, but it doesn't make much sense in the real world application. But that's okay. Just keep in mind, don't freak out when you see a negative number in there. Okay? Thanks for sitting through all this. I know it was a lot of calculating and thinking, and it's not always easy, but keep working hard and you'll get through this section. Thanks for watching, and I hope you're having a great day.